Welcome to our deep dive into the fascinating world of distillation in chemistry. Distillation is a powerful technique used to separate mixtures based on differences in their boiling points. Whether you're in a laboratory or an industrial plant, this process is essential for purifying liquids and obtaining specific components from complex mixtures. Today we'll explore how distillation works, its history, the equipment involved, and its many applications. By the end of this video, you'll have a clear understanding of why distillation remains a cornerstone of chemical science. Its core, distillation, relies on the fact that different substances boil at different temperatures. When a mixture is heated, the component with the lowest boiling point vaporizes first. This vapor is then collected and condensed back into a liquid, effectively separating it from the rest of the mixture. This simple yet ingenious principle allows chemists to isolate pure substances from solutions or mixtures, making distillation a fundamental process in both research and industry. Distillation has a rich history dating back thousands of years. Ancient civilizations such as the Egyptians and Greeks used early forms of distillation to create perfumes and medicinal extracts. Over time, the process evolved, with alchemists in the Middle Ages refining the technique to produce spirits and essential oils. Today, distillation is a highly controlled and precise method, but its roots remind us of humanity's long-standing quest to separate and purify substances. To perform distillation, several pieces of specialized equipment are required. The most common setup includes a distillation flask, a heat source, a condenser, and a receiving flask. The mixture is heated in the distillation flask, and as the vapor rises, it passes through the condenser, where it cools and returns to liquid form. Each component plays a crucial role in ensuring the process runs smoothly and efficiently. Simple distillation is the most basic form of the process. It's used when separating a liquid from a solution where the boiling points of the components differ significantly. The mixture is heated, and the component with the lower boiling point vaporizes and is collected. This method is ideal for purifying water or separating alcohol from a fermentation mixture. The boiling points of the components are closer together. Fractional distillation is used. This method employs a fractionating column, which provides a larger surface area for repeated vaporization and condensation cycles. As the vapor rises through the column, the component with the lower boiling point moves further up, allowing for a more precise separation. Fractional distillation is commonly used in the petroleum industry and for separating complex mixtures. Vacuum distillation is a variation where the pressure above the liquid is reduced, lowering the boiling points of the components. This is particularly useful for substances that decompose at high temperatures. By distilling under reduced pressure, chemists can purify heat-sensitive compounds without causing them to break down, making this technique invaluable in organic chemistry and pharmaceuticals. Steam distillation is used to extract temperature-sensitive compounds such as essential oils from plants. In this method, steam is passed through the plant material, causing the volatile compounds to vaporize at lower temperatures. The vapor is then condensed and collected, separating the desired oils from the rest of the plant matter. This gentle technique preserves the delicate nature of the extracted substances. Azeotropic distillation tackles the challenge of separating mixtures that form azeotropes, mixtures with constant boiling points that behave as a single substance. By adding another component or changing the pressure, chemists can break the azeotrope and achieve separation. This advanced technique is often used in the production of high-purity solvents and fuels. Distillation isn't just for the laboratory, it's all around us. From the purification of drinking water to the production of spirits and perfumes, distillation plays a vital role in our daily lives. Even the gasoline that powers our cars is refined through distillation. Understanding this process helps us appreciate the science behind many everyday products. On an industrial scale, distillation is used to separate and purify large quantities of chemicals. Oil refineries, for example, use massive distillation columns to break crude oil into useful fractions like gasoline, diesel, and kerosene. The efficiency and scalability of distillation make it indispensable in manufacturing, pharmaceuticals, and food processing. In the laboratory, distillation setups are designed for precision and safety. Glassware is carefully assembled to ensure a tight seal, and temperature is closely monitored. Safety equipment, such as heat-resistant gloves and goggles, is always used. This attention to detail ensures that the process is both effective and safe for chemists. Condensers are a vital part of any distillation apparatus. They cool the vapor back into a liquid, allowing it to be collected in a separate container. There are various types of condensers, such as Liebig and Graham condensers, each suited for different applications. The choice of condenser can impact the efficiency and purity of the distillation process. Heating is a crucial step in distillation. Common methods include using Bunsen burners, electric heating mantles, or hot plates. The choice depends on the scale of the operation and the nature of the substances being distilled. Consistent and controlled heating ensures that the process proceeds smoothly and safely. Accurate temperature measurement is essential during distillation. Thermometers are placed at strategic points in the apparatus to monitor the boiling point of the vapor. This helps chemists determine when a particular component is being collected and ensures the purity of the final product. Distillation flasks are specially designed to withstand high temperatures and pressure changes. They come in various shapes and sizes, such as round bottom or pear-shaped, each suited for different types of distillation. The choice of flask can affect the efficiency and safety of the process. The receiving flask collects the purified liquid after condensation. It must be compatible with the rest of the apparatus and able to handle the volume and type of liquid being collected. Proper selection and placement of the receiving flask are important for a successful distillation. Fractionating columns are used in fractional distillation to improve separation. They are filled with materials that provide a large surface area for repeated condensation and vaporization. This allows for a more precise separation of components with similar boiling points, making the process more efficient. Distillation curves are graphical representations of the boiling behavior of mixtures. By plotting temperature against the volume of distillate collected, chemists can analyze the efficiency of the separation and identify the composition of the mixture. These curves are valuable tools for optimizing distillation processes. Two important measures in distillation are purity and yield. Purity refers to how free the collected substance is from impurities, while yield measures how much of the desired component is obtained. Balancing these two factors is key to a successful distillation, especially in industrial and research settings. Distillation is used in a wide range of applications. In addition to water purification and oil refining, it's essential in the production of alcoholic beverages, perfumes, and pharmaceuticals. The versatility of distillation makes it a go-to method for separating and purifying liquids in many industries. One of the most important uses of distillation is in producing clean drinking water. By boiling water and collecting the condensed vapor, impurities such as salts and microbes are left behind. This method is especially valuable in areas where water sources are contaminated or scarce. Distillation is central to the production of alcoholic beverages. After fermentation, the mixture contains alcohol and water along with other compounds. Distillation separates the alcohol, allowing for the creation of spirits like whiskey, vodka, and rum. The process also helps control the flavor and strength of the final product. The fragrance industry relies on distillation to extract essential oils from flowers, herbs, and spices. Steam distillation is often used to preserve the delicate aromas and properties of these natural substances. This process allows perfumers to create complex scents and therapeutic oils. In the pharmaceutical industry, distillation is used to purify solvents and active ingredients. High purity is essential for the safety and effectiveness of medicines. Distillation ensures that only the desired compounds are present, free from contaminants that could affect patient health. Petroleum refining is one of the largest applications of distillation. Crude oil is separated into fractions like gasoline, diesel, and jet fuel using massive distillation towers. Each fraction has a specific boiling range, allowing refineries to produce a variety of fuels and chemicals from a single raw material. Distillation also plays a role in environmental protection. It's used to treat wastewater, recover solvents, and remove pollutants from industrial streams. By separating harmful substances, distillation helps protect our water supplies and reduce environmental impact. In the food industry, distillation is used to concentrate flavors, purify ingredients, and create extracts. For example, vanilla extract and certain food colorings are produced using distillation. This process ensures that food products are both flavorful and safe for consumption. Researchers use distillation to isolate and study new compounds. By separating mixtures into their individual components, scientists can analyze their properties and develop new materials. Distillation remains a fundamental tool in chemical research and discovery. Safety is paramount when performing distillation. Proper ventilation, heat-resistant gloves, and eye protection are essential. Chemists must also be aware of the properties of the substances they're working with, as some can be flammable or toxic. Following safety protocols ensures a successful and incident-free distillation. Distillation can present several challenges such as bumping, foaming, or incomplete separation. These issues can be addressed by adjusting the heating rate, using anti-bumping granules, or optimizing the apparatus. Troubleshooting is an important skill for anyone working with distillation. Distillation can be energy-intensive, especially on an industrial scale. Engineers are constantly seeking ways to improve efficiency, such as using heat exchangers or integrating multiple distillation columns. These innovations help reduce costs and environmental impact. Modern distillation processes often use automation to monitor and control temperature, pressure, and flow rates. Automated systems improve consistency, safety, and efficiency, allowing for large-scale operations with minimal human intervention. While distillation is highly effective, it's not the only separation technique available. Methods like filtration, chromatography, and extraction are also used, depending on the nature of the mixture. Understanding the strengths and limitations of each method helps chemists choose the best approach for their needs. As with any industrial process, distillation can have environmental impacts such as energy consumption and emissions. Advances in technology are helping to minimize these effects through improved efficiency and the use of renewable energy sources. Responsible management ensures that distillation remains sustainable. Recent innovations in distillation include the development of membrane distillation and hybrid systems that combine multiple separation techniques. These advances offer greater selectivity, lower energy use, and the ability to handle challenging mixtures. The future of distillation is bright, with ongoing research driving new possibilities. Distillation is a staple of chemistry education. Students learn the principles of boiling points, phase changes, and separation techniques through hands-on experiments. These experiences build a strong foundation for future studies and careers in science. Throughout history, distillation has led to significant scientific discoveries. The isolation of pure chemicals, the development of new medicines, and the creation of synthetic materials have all been made possible through distillation. These breakthroughs highlight the importance of this technique in advancing science. Distillation isn't limited to Earth. Scientists are exploring its use in space missions to recycle water and produce fuel from waste. These applications are crucial for long-term space travel and the sustainability of life beyond our planet. Looking ahead, the future of distillation will be shaped by advances in materials, automation, and sustainability. Researchers are developing new membranes, sensors, and control systems to make distillation even more efficient and environmentally friendly. These trends will ensure that distillation remains a vital tool for generations to come. Distillation has also influenced art and culture. From the creation of fine spirits to the crafting of perfumes, this process has inspired creativity and tradition. Its presence in literature and folklore reflects its enduring significance in human society. There are many myths surrounding distillation, such as the belief that it can remove all impurities or create dangerous substances. In reality, distillation is a controlled and precise process, but it does have limitations. Understanding the facts helps dispel misconceptions and promotes safe, effective use. Home distillation is becoming more popular for water purification and hobbyist projects. While it can be rewarding, it's important to follow safety guidelines and local regulations. With the right equipment and knowledge, home distillation can be a safe and effective way to produce pure substances. Distillation is a versatile and essential technique in chemistry, used to separate and purify liquids based on their boiling points. From ancient history to modern industry, its applications are vast and varied. By understanding the principles, equipment, and safety considerations, anyone can appreciate the value of distillation in science and everyday life. Thank you for joining us on this journey through the world of distillation in chemistry. We've explored its principles, equipment, applications, and future trends. Whether in the lab, industry, or at home, distillation continues to play a crucial role in our lives. Stay curious and keep exploring the wonders of science.